So this is the second part of your video. We had just finished talking about rational numbers. So I'm just going to quickly talk to you about what an irrational number is. So when I'm looking at irrational numbers, I've got things that basically anything that is not rational is an irrational number. So it's a decimal that never stops or repeats. So if it doesn't stop or repeat and it just goes on forever in just some random form, then it's an irrational number. So for example, pi is an irrational number because it's 3.14159, etc., 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 and it never repeats. So that would be what's called an irrational number. All right, so if we move on to the next thing that we're going to be talking about, it's basically how are we going to recognize if rational numbers are the same. So I can determine, say I have, so this is your first example, which numbers are the same. Because you know that there's a lot of different ways that we can represent numbers. So for example, if I had negative 3 over 2, and then I had negative 3 over negative 2, and then I had negative 6 over negative 4, and I had negative 1 1/2 and negative 1.5, I need to figure out if all of these numbers are the same or not. So what I'm going to do is I'm going to try and get them all in the same form. So if I start looking at them, what I'm going to do is either convert them all into decimals or all into fractions. In this case, this is a really easy one to work with. I'm probably going to convert them all into fractions, but I need to know which one is positive and which one is negative. So this first one has a negative divided by a positive. So I know that in the end that's going to be a negative. This one right here has a negative divided by a negative, and I know that ends up coming out as a positive always. This one over here has a negative divided by a negative, so that's going to come up positive. This whole thing right here is negative, and so is this. So right off the bat, I know these two are different. I need to check how different. So negative 3 over 2, I could quickly convert that back into a mixed number. So how many times does 2 fit into 3? 1 whole time. And then there's 1 out of 2 left. Okay, so right off the bat, I know it's the same as this guy over here. These two. Over here, even though this is different, so this one right here, even though this one's different, it's a positive, I know I can look at 3 over 2 and have it as 1 1/2. If I reduce this third one here, I know that 6 can be divided by 2, 4 can be divided by 2. So this will end up as 3 over 2, which I know is 1 1/2. This one I've already dealt with. So here I'm just looking over at the final one, negative 1.5. Now, you really should know that 1 1/2 is the same as 1.5, or negative 1 1/2 is the same as negative 1.5. We should know that because those are fractions we should just know right off the bat. If I forget that, what I can do is take the fraction part and go 1 divided by 2, and that's going to give me 0.5. So I'm going to have 1 plus 0.5, gives me 1.5. Okay? So all of these numbers have the same actual number part, but the signs are different. So some are positive, some are negative. So I know that these two are the same, and then the 3 that are left over are all the same. Okay? So you need to get them all in the same form, either all into the same fraction form or all into the decimal form if they're not easy to just figure out right off the bat. The next thing we're going to do is list numbers. So list rational numbers between two values. So in this case, we're going to list rational numbers between negative 1/5 and negative 1/3. Now these aren't easy to see right off the bat on a number line. what are some of the fractions that are in between? And a lot of people will answer, well, -1/4 is definitely in between. And actually, that won't always be the case, okay? So I can't just right off the bat go ahead and just guess. What I need to do is get common denominators. And if you were working with decimals and fractions, you would need to get them both into decimal form or both into fraction form. And you should be taking notes on this with what I'm saying, okay? So you should get a common denominator. If I look at a common denominator for 5 and 3, I know that's going to be 15. If you are struggling with remembering how to get common denominators, you need to get help on that right away, because I'm going to have to assume that you actually know what that is, because that's from a lot of years ago. So now I've got -3/15 and -5/15. So if I want to say list 3 rational numbers between -1/5 and -1/3, I'm going to have to figure out what's in between these two guys now. Now I know if I look at the tops, there's a space in between -3 and -5. So I'm always looking at the tops because that's how many of something I have. So a number in between that would be -4/15. But that's not enough. I need 3 of those guys. So what I'm going to have to do is get common denominators again that are a little bit smaller. So I'm going to multiply both of these fractions again, and I'm going to do that on the next page. So I had -3/15 and -5/15. And I know that I'm going to have to multiply these fractions by another integer to make them, chop them into smaller pieces, so there's more pieces to choose from. So if I multiply it by 2, which is always a good thing to do, just multiply it by the smallest number you can, I'll get -6/30 and -10/30. Now if I look at the numerators here, there definitely is 3 different numbers between -6 and -10. Those numbers are -7/30, -8/30, and -9/30. So I have to keep multiplying the fractions by a number. So keep multiplying the fractions until I get a denominator that's big enough. Okay? And that is all I'm going to talk about today. Okay, so once you've got that written down, you're done the homework. When you come into class, what we're going to do is practice some questions on this. Oops. All right. Goodbye, grade 9s. I will see you tomorrow. Actually, I won't. We don't have math tomorrow, so I'll see you on Monday. Bye, guys.